Did it. I freaking did it. Oh my god. So, if you take the quantity of outrage you feel every morning reading the news, and you take the square root of that number, you get pi. And if you multiply pi by the diameter, you get a circle. So basically, what I figured out is that anger is a circle. It's an endless circle of despair. Huh. Hey everyone, I'm Rahi Patel, and you're watching The Hard Problem. How do you mathematically define consciousness? For the longest time, consciousness has stayed within the realm of philosophy. But now, with new technology and a growing understanding of the brain, we can begin to create testable theories about the mathematical basis of consciousness. We've traced the history of our universe back to fractions of a second after its birth with great mathematical precision. So why has it been so difficult to accomplish a similar feat with the origins of consciousness? The problem is, we just aren't even close to having the technology to properly study the one machine we know can produce it. The brain has 86 billion neurons and approximately 100 trillion connections. Right now, our imaging capabilities can tell us whether certain regions of the brain are slightly more active than others when people are performing certain tasks. The regions themselves contain thousands to millions of neurons. It's currently a very crude way of figuring out how the brain works. It's actually a bit like trying to learn how all the transistors work on this computer without being able to take it apart. Where even are the screws on this thing? Apple. If we want a better picture of how consciousness arises, that's not going to be good enough. We're going to need to seriously advance our tech. And I'm confident we will. A lot of smart people are working on it right now. But it'll take time to get there. In the meantime, it can't hurt to make educated guesses based on what we do know. There are currently two theories out there that many scientists are paying attention to. The first is called Integrated Information Theory, or IIT for short. The main idea for this theory is that consciousness is a result of neurons being organized and connected in a particular way. The theory starts off by trying to describe fundamental aspects of consciousness. For example, when you look at this object, you see an orange square. But no matter how hard you try, you can't see the color orange separately from the square. The theory then tries to predict what a physical system should look like to allow for these aspects of consciousness. In the case of our brains, the physical system is neurons and their connections. However, the theory can also be applied to logic gates in computers. The properties of the system can be defined by a bunch of math, like a whole lot of it. But all that math culminates in what I think is a truly epic number, called phi. Theoretically, this number tells you how conscious a system is and what that conscious experience is like. If this theory is right, it means that consciousness lies on a spectrum, and it's likely that most animals have it too. It also means that we could potentially design computers that are conscious. The theory has explained some facts about consciousness and the brain, but it still has a ways to go. To completely prove this theory, we're going to need a lot more computational power and a much more detailed map of the structure of the human brain. The other theory that's pretty well regarded is called Global Workspace Theory, or GWT for short. This theory kind of takes the opposite approach to integrated information theory. It starts by evaluating countless studies done in neuroscience and psychology, and collapses them all into a model of how the human brain works. The theory proposes that the brain is made up of unconscious processors. As the name suggests, these processors perform certain tasks unconsciously. For example, the part of your brain that processes language would be considered an unconscious processor. The unconscious processors can't communicate with most of the other processors directly, but can compete to send information to something called a global workspace. By some selection process, information from a specific unconscious processor gets accepted into this global workspace and is then broadcasted to all unconscious processors in the brain. According to the theory, consciousness is associated with this global workspace. Some scientists are creating computational models of GWT to see if it can perform human-like tasks. If developed further, the code could potentially lead to machine consciousness. Like IIT, a lot of work needs to be done to verify this theory. But if it's right, it means that only physical systems with this kind of architecture can be conscious. For example, fish could not be conscious according to this theory, because their brains aren't properly structured. So, we have two theories that are trying to figure out what consciousness is, but are each tackling the problem from different angles. Integrated information theory starts from the subjective properties of consciousness and figures out what a physical system should look like to give rise to those properties. On the other hand, global workspace theory is taking the mountain of research on the physical properties of the brain and is trying to see how consciousness fits into the picture. Neither of them can be entirely proven or disproven yet because of our limited understanding of the structure and dynamics of the brain. But that doesn't mean we can't learn anything from them. If you want to learn more about IIT and GWT and the fascinating pictures they paint of our mind, stay tuned for the respective series. But for now,